Hey guys, Mrs. Brown here, and we are starting our Myers Unit 4, Sensation and Perception. This is going to take us through how we take in sensory information and how our brain perceives that information and makes sense of it and organizes it. So we're going to start today with sensation. This is from Module 16. And sensation is the process by which our sensory receptors and nervous system receive stimulus from the environment. So another good definition of this is the detection and coding of stimulus energies by the nervous system. So taking in any sort of sensory information, whether it be touch information, visual information, auditory information, or olfactory information, and sending that to the brain in order to process and make sense of that information. Now, this little guy here is homunculus, okay? And homunculus shows us how our sensory receptors are distributed in our body. So what's interesting to understand is that we actually have more sensory receptors on the parts of our body that take in more sensory information, okay? So they send this information to our somatosensory cortex and the motor cortex. We talked about the parietal lobe and how that processes body information. But if you look at homunculus, he has giant hands, giant lips, and a giant tongue. And that's because a lot of our sensory receptors are located on these parts of our body because these are things that help us take in sensory information. All right, so we do send that information. Remember, our sensory neurons, our afferent neurons, send that information to the brain. And the two parts that we're going to be looking at here, the somatosensory cortex and the primary motor cortex, help us to make sense of that sensory information. Once we've gained that sensory information, we need to organize it, make sense of it, and interpret it. This process is called perception. All right, so a good definition for perception, this is also from Module 16, the processing of selecting, organizing, and interpreting sensory information, which enables us to recognize meaningful objects and events. Now, there are two different ways that we can think about processing, top down and bottom up. Bottom-up processing starts with sensation and ends with perception. We'll detect specific parts of a stimulus, then we'll make sense of it and we can recognize it. Okay, so for example, if you were to see a bunch of trees, we would see the trees, your brain would send the information about there being trees, and then you would be able to recognize that and label it, it's a forest. Okay, top-down processing starts with a perceptual hypothesis, and then you make sense of that hypothesis by piecing together sensory stimulus information, okay? So you would say, I know what a forest is. Let me look for trees and see if it is in fact a forest, starting with perception and working down to sensation. So we definitely want to know these two, okay? Bottom up begins with sensory receptors, and top down starts with thinking, perception, and then goes to the sensory information. So here's, this is actually an optical illusion, but I want you to take a look at this. Okay, what do you see first in this picture? What do you see this as a picture of? If you were a person who said, this is a scene from a forest or a wildlife, or you saw the horses in the forest, that may be that you are seeing this as top down, okay? Then you may see the individual faces. There are faces here. There's one, there's one, there's one, there's one, there's one, there's one. If you see those second, again, you saw the forest first, then the faces, top down. If you saw the faces first, and then you realize, this is actually a forest scene, that would be an example of bottom up. All right, so with sensation, we need to talk about, what makes you notice things? what makes you take in that sensory information. So we want to talk about absolute threshold and difference threshold, okay? Absolute threshold is the minimum amount of stimulation a person needs to detect a stimulus 50% of the time. The minimum amount of stimulation a person needs to detect a stimulus 50% of the time. So this could be a visual stimulus, this could be auditory stimulus, this could be an olfactory, a smell stimulus. What does it take for you to notice that? Okay, so you know, how many pretzels does Auntie Anne's counter need to make before you can smell it in the mall? Or how many squirts of perfume does someone need to wear before you notice that they're wearing perfume? Or how close does someone need to be holding a candle to you before you can see that candle on a dark night? Okay, so if you consistently can notice a stimulus at least 50% of the time, whatever the level of that stimulus or the amount of that stimulus or the distance of that stimulus, where you can start to recognize it at least 50% of the time, that's what we call the absolute threshold, okay? Not to be confused with absolute threshold level being met for a neuron firing, right? That was something else. But for absolute threshold, this varies from person to person. Some people have lower absolute thresholds or some people have higher. For example, my absolute threshold for noticing a smell would probably be much lower than my grandmother's absolute threshold for noticing a smell because her sense of smell has deteriorated as her sense of taste has deteriorated as she ages. So this could be different for each person. So let's take a look at some examples here. All right, so for smell, if you're trying to notice that there is perfume being diffused, all right, if someone can notice at least half of the time that there is perfume being diffused when only one drop is being diffused, then their absolute threshold would be 1 drop. Okay, this is a silly one. The wing of a bee falling on your cheek from a height of 1 centimeter. So if they started noticing at 1 centimeter that a wing of a bee fell on their cheek at least 50% of the time, this would be a hilarious trial to do, by the way. I can only imagine. But that would be the absolute threshold. Okay, then what happens when you're trying to talk about more than one stimulus? Maybe you have 2 stimuli or more, and you're trying to notice differences or compare the two. This is when we would use the difference threshold, okay? This is also called the just noticeable difference because it's just noticeable. It's the minimum amount needed for you to notice a difference at least 50% of the time. Okay, so difference threshold and JND are the same thing. The minimum difference that a person can detect at least 50% of the time. So this could be visual differences between 2 different things. This could be smell, touch, sound, or sight. So I always like to play these games in magazines. I had magazines as a kid where you'd have 2 different pictures and you have to notice a difference between the 2. So take a look and I want you to spot the differences and see how many differences you can detect. You can pause this video if you need to. All right, so some people may not have noticed that these were different at first. Some people noticed right away. So if we were trying to find the difference threshold, it would be the minimum amount of differences between these 2 pictures that it would take you to notice that these were different. For example, some people would notice the tiniest difference, like the bracelet not being on this girl's wrist. That may be that they have a difference threshold of 1 item. Okay, some people might need 50 items being changed to notice that there's a difference. So everybody's difference threshold is a little bit different, okay? Now, for those of you who are wondering about this picture, these are all the different things that were different. So if you were trying to find these, there you go, okay? Now, another concept for sensation is Weber's law, okay? Weber's law says that in order to perceive a difference between 2 stimuli, that they have to differ by a constant proportion. They have to differ by a constant proportion, such as a percentage, and not necessarily a constant amount. Okay, so a lot of the times we use Weber's law when we're talking about like, is it worth it kind of thing. Okay, so would you drive 10 minutes away to save $20 on a meal? Well, it's not necessarily the amount, right? According to Weber's law, it's the proportion. So how much is the meal going to be? If the meal itself is going to be, you know, a $200 meal, $20 doesn't sound like that much. You might say, whatever, what's $20 more when I'm going to spend $200 on a meal? But if the meal is $25, right? You may drive 10 minutes to save $20. That's a much larger percentage of your cost that you're saving. So we'd notice the difference of that $20 because it's a certain percentage of the overall cost and not just a constant amount, right? Saying, you know, do you want to save $5? Well, sometimes I do and sometimes I don't. You have to put it in the context of what proportion that $5 is. Okay, would you drive across town to save $100 on a $30,000 car? Probably not, right? Probably not. If you're being honest, you know, if you're dropping money on a $30,000 car, $100 is not a lot, right? So it's not really worth it. Another example of Weber's law is sometimes we do an experiment in class. Unfortunately, we can't do that right now, but where I have cups and I have coins taped to the inside of the cup. And if it's just one or two coins different and the students are lifting the cups up, they can't tell that they have different amounts of coins. They can't notice the difference of coins. But once you get to a certain percentage of coins, and you can really feel the difference in the weights, that's when they can start to notice, okay, you know, this one is heavier than the other one. All right, another thing we want to talk about with sensation is called sensory adaptation. Okay, and we need to make sure that we understand the difference between sensory adaptation and something called habituation. Sensory adaptation is diminished sensitivity. So you lose sensitivity for something as a result of constant stimulation to an unchanging stimulus. For example, assuming you don't have any problems with your underwear, like they're too small or there's something wrong with them. Usually we don't feel our underwear throughout the day. We stop paying attention to the feeling of wearing underwear as long as there's no problems because we have constant stimulation to them. They're on our body all day. So as a result, we're not paying as much attention to them, okay? The same thing like when you get into a cold pool, a swimming pool. When you first get in, it's really cold. And then you always say, oh, well, once you get used to it. Well, do you get used to it? Because the water temperature itself is not changing, right? You just have sensory adaptation to that. You have diminished sensitivity to that cold because of the constant stimulation of that cold water, okay? Now, one thing we want to make a distinction about is a concept called habituation. Habituation is stimulation over multiple exposures. So we like to know the difference between not paying attention to a stimulus because of one continued exposure, which would be sensory adaptation, and multiple exposures, which would be habituation. An example of habituation is not hearing or paying attention to a train sound because you live near the train tracks and you hear it all the time, okay? Or, you no longer care about your husband snoring because you hear it every night. It is like a continuous thing that happens over a certain number of times, habituation. Sensory adaptation would be continuous exposure over one time. For example, I was sleeping and at first I couldn't fall asleep because of the snoring, but as I continued to hear it all night, I got used to it. Just that one night, then sure, that would be sensory adaptation. But if you're saying I no longer hear the snoring because I hear it every night, that would be habituation. So we want to make sure we understand these two concepts. Another concept we want to understand for sensation and perception is selective attention. All right, in order to take in sensory information, in order to even have sensation, we need to use selective attention because there's so much sensory information coming in at one time. We choose what we want to pay attention to. All right, sometimes we choose wrong, and this causes us to miss critical information. So hopefully you're selectively attending to this information right now. But the focusing of conscious awareness on a particular stimulus. How do I know to pay attention to my teacher and not to the girl who's chewing gum loudly next to me? Because I choose to selectively attend to my teacher and to tune out the girl who's chewing gum next to me. It may be that I even have some sensory adaptation to the girl who's chewing gum, and after a few minutes, I don't even hear it anymore. But we choose to selectively attend because there's so many different things that are coming at us at once. We can't possibly take in everything. So in order to take in sensory information, we do use selective attention. This is part of the reason why people with ADHD struggle to pay attention sometimes, is because they lack the ability sometimes to tune out information, and they struggle with selective attention. Sometimes they focus on what is not important at that moment, or sometimes they have so much coming in at once that it can feel overwhelming. Now, one example of the selective attention idea is called the cocktail party effect. And this one loves to show up on the AP exam, especially on FRQs. The cocktail party effect is an example of selective attention. And what it says is that we have the ability to listen to one voice among many. And the idea is that when you're at a party, which for adults, they sometimes call them cocktail parties, okay? You can talk to your friend, even though it's a crowded, noisy environment with lots going on, you're still able to selectively attend to your friend's voice and hold a conversation with your friend. All right, an example for you guys, if you were in the football stadium and a noisy, crowded pep rally or a noisy, crowded sports game, and you were still able to focus on one voice and talk to your friend, that would be an example of the cocktail party effect, which demonstrates your ability to use selective attention. All right, the last thing I want to talk about with sensation before we get into specific sensations and different senses such as vision and audition and all the other senses we want to talk about is how do we get that sensory information and how do we even convert it to something that our brain can use? And the process is called transduction. Transduction, this is from Module 18, conversion of one form of energy to another. All right, so this helps us to change stimulus energies to take in the sensation and change it into neural impulses. Take in the sensory information and change it into something that's usable by our brain. All right, so we can transduce light energy into vision. We can transduce chemical energy into gustation and olfaction, gustation being taste, olfaction being smell, and we can transduce sound waves into sound. Here's an example. The local fire department sounds the 12 o'clock whistle. Really, we should say alarm. The process by which your ears convert the sound waves from the siren into neural impulses is an example of transduction. And this is a good example to remember. All right, we're going to stop here and then we will get into the individual senses and information about those senses in the next part. Thanks. See you later.